Hello class, we're about to start section 7.1, graphing quadratic functions in vertex form. The basic parabola graph, fill in the table for f of x equals x squared, then graph by hand. So we have some values here. We have from -5 to +5. Now when we put this in our calculator, we would end up with these values: 25, 16, 9, 4, 1, 0, 4, 9, 16. Actually, I skipped one. Actually, this should have been 1, 4, then 9, 16, and 25. Okay, so these are our values. Now, what we need to do is we need to plot these points. We have 0, 0. We could start from the top, -5, 25. We had -5, and this is 24, so this would be 25. And then we would have, what's that, -4, 16. Let's see, which is here. And then we would have -3, 9. And then we have -2, 4. Then we have -1, 1. Then we had our 0, 0. Then we have 1, 1. And then we have 2, 4. We had 3, 9. And we have 4, 16. And finally, we have 5, 25. Now, we will connect these points. Now, of course, you would be able to do it a little bit better than me, but this is supposed to form the shape of a parabola. We have our arrow here. Now, one thing that I want you to know is this here. The vertex is the lowest or highest point of your graph here. And it's also the point that separates everything. And let me explain what that means. So our point here, our vertex, would be 0, 0. So it is an x and y value. But if you notice here, from 0 being x, when you go down 1 or up 1, you notice that their y values are the same. When you go down 2 or up 2, and I'm talking as far as negative and positives are concerned, their y values are exactly the same. Go up 3 or down 3 and up 3, you notice their y values are the same. So this here 0, 0 is your vertex. And this graph here is opening upward. Whenever your graph opens upward, that means that the vertex point is the lowest point. Now we go up here to objective 1. It says the graphs of f of x is equal to x squared, g of x is equal to 2x squared, and h of x is equal to 4x squared. Now you can put this into your calculator so you can get a visual representation of this. But if you look here, I'm going to use different colors. The one that is the widest here is considered to be your x squared. So let me use green for that. Now I'll just put this here. It's kind of hard to trace over this, but you get the general idea. This right here would be actually your x squared graph. So this is your x squared. Now your 2x squared would be the graph in between this widest graph and the narrower graph here. So what I'm going to use there, I think I'm going to use this this marker here. Let's see. Yeah, I think that'll be good. Yeah, I use this purple marker. I guess that purple marker just a little too thick. Let me get rid of that. All right, let me try. Let's try. Matter of fact, we could just leave that black. Just leave it the same color. So then that would be 2x squared. And then this gray one here, we can use this one. We can leave that gray. And then that would be our 4x squared. Let's see, I don't have gray as a color, but I'll just put this here. That's close to gray. So this is our 4x squared, our 2x squared, and our x squared. Now, of course, one other thing, these are supposed to have arrowheads. Just put these arrowheads here because these graphs go on forever. So now, it says here, label each graph, which we did. It says the larger the value of A, the blank the parabola. Now, one thing you need to know, A is the coefficient of these variables here. So we had x squared, we had 2x squared, and we have 4x squared. Now this one, A is 1. So I'll write A equals 1. And then the 2x squared, we know A would be 2. And we know the 4x squared, we know that A would be 4. So now, the larger the value of A, the narrower the parabola, or you could say skinnier. Or you could say the skinnier the parabola would be. Okay, so now we scroll down here. We have our next graph. It says the graph of fx is equal to x squared, g of x is equal to 1/2 x squared, and h of x is 1/5 x squared. Now we know the larger a is, the narrower it is. So let's see. With this f of x, we know a is 1. With this g of x, a is 1/2. And then we know with the h of x, a is 1/5. Now we know 1/5 is smaller than these other two. So we know that this right here has to be our h of x. And then here we know that 1/2 is less than 1. So we know this will have to be our g of x. And then finally, this real wide graph here will have to be our f of x. I'm sorry, this more narrow graph has to be our f of x. So what we notice here is the smaller the value of a, the blank, the parabola. We know it's the wider. So we know this is f of x graph, this is g of x graph, and this is h of x's graph. So now we scroll down. It says the graph of f of x equals negative x squared, g of x is a negative 1/2 x squared, and h of x is a negative 2x squared. Now if we look here, we have our a, with our first is negative 1. Our a for our g of x is negative 1/2. And our a for our h of x is negative 2. Now first of all, we have to look at it like this here. Now, again, remember, we're doing negative a's. Now, remember, with the positive a's, we knew that the larger the a was, the more narrow it got. And since we're doing the opposite with the negatives, and if you notice here that your parabola is flipped upside down, we would do the opposite here. Whichever one is the smallest value would be the narrower amount. So we look here. Of all of these numbers here, we know negative 2 is the smallest, our a being negative 2. So we know that this graph here, this gray one, let me put our arrowheads here. We need to put our arrowheads. So we know the most narrow graph would be our h of x, because we know that the a value here is smaller than all of the rest. Now the next smallest would be negative 1. So then negative 1 is actually our f of x. So then our next value here would be f of x. And then finally, with this last parabola here, we know this would be our g of x, because that is the larger value. Now remember, with negatives, we do the opposite. So whatever is our smallest value will be our narrowest graph, and whatever is our largest value would be our wider graph. And that's only when we're dealing with the opposite signs. Okay, so we labeled each graph, which we did. We have f of x equals ax squared, g of x is equal to negative ax squared. They are reflections of each other across the x-axis. Now, if the absolute value of a is greater than 1, the parabola is narrower than if the absolute value is less than 1. So basically, this is what this is saying. If you notice here, when we did if we did the absolute value of a, the absolute value of negative 2 would give us positive 2. That is greater than 1, so that would be the narrower value, which we marked here, which is our h of x. So this actually holds up here. Now, as far as this is concerned, if this is the narrower part, then anything that's less than 1 will be actually wider than the ones that has the absolute value that's greater than 1. So now we scroll down. It says here, if a is greater than 0, now we know that that would mean that a will be positive. So we know that's positive. So this is, let me rewrite that. I thought this was going to jump. So a is positive. When a is greater than 0, we know a is positive. Then the parabola opens upward. When your a is positive, it opens upward. If a is less than 0, now we know that that means negative. So that means if your a is negative, then the parabola opens downward. If the absolute value of a is a large number, then the parabola is narrower. If the absolute value of a is a small number, near 0, then the parabola is wider. Now remember, this basically only applies to, well, actually it applies to both, whether it's positive or negative. Okay, now we come here to objective number 2. It says, functions of the form f of x is equal to x squared plus or minus k. The graph of f of x equals x squared, and g of x is equal to x squared plus 5, and h of x equals x squared plus 8 are drawn. Label each graph, explain how the values of k affects the graphs. Okay, now, here's the thing. First of all, we know what our k is here. Our k and g of x is 5. So we know that's k equals 5. Our k here is 8. So k is equal to 8. Now right here, you don't see a k. But here we should know that our k is equal to 0. Now, we know f of x equals x squared would be this gray graph here. We already graphed that earlier. So we know that this graph here will be our f of x. Okay, now we have to deal with these other two graphs here. If you put these in your calculator, you notice that when you put in x squared plus 5, let me put these arrowheads here, all of the arrowheads. Okay, now when you put in x squared plus 5, you notice that your graph shifted up 5. So then this would be your g of x. This black graph here is your g of x. Now finally, the gray graph, we have plus 8. The graph shifted up 8 places. So this would be our h of x. Now, what you would put here for b is shifts the graph up if k is positive. So that is what explain the values of k, how it affects the graph means. shifts the graph up if K is positive.